All right, so we got the givens. Measure of angle ACB equals 110. Measure of angle CDE equals 40. Measure of angle B. Yeah, everybody should have got given. That's right. Yep. All right, so let's take what you said about the triangle having to be 180. Let's use that. All right, so triangle. All right, we're looking to get triangle ACB. So angle ACB plus angle A plus angle B. Isn't that the one you said? We know that's 180 degrees, right? Triangle sum. Triangle sum theorem. Mm-hmm. Yeah. Yeah. We learned that all angles in a triangle add up to be 180. Right? Yeah. Triangle sum. All right. And then we know that the measure of angle ACB is 110. All right. And we know that measure of angle B is 30. So what have I done? I've substituted the angles that I knew. And then I'm going to, I wrote 4, it's supposed to be 5. Can't count. I can do a proof, but I can't count. It's okay. No panic. So I'm going to say the measure of angle A plus 140 degrees equals 180. What's the reason that I can do that? Well, I just simplified. Yeah, that's all I did. Okay. And then I can find the measure of angle A from that. Yeah. Heck, you can just put subtraction problem. You don't have to put of equality. We know that's what it is. And if we know that the measure of angle A is 40 degrees, what else do we know that is 40 degrees? Angle CDE is also 40 degrees. So we know that measure of angle A is equal to measure of angle CDE by substitution. And then that creates angle A is congruent to angle CDE. What's the reason for that? Yeah, definition of congruence. All right, so if we're trying to prove two triangles similar, everything we have about this is about angles, right? So what are we trying to prove through? Similarity through angle. So right now, we only have one pair of congruent angles. The corner that they share, exactly right. So we need to say that. We know it's there. It's obvious that that's the shared angle, but we've got to state it in our proof. So we're going to say that angle ACB, I'm going to name it from the triangles that I'm trying to get there, and then angle DCE And that's the same angle, so it's reflexive. Angle C is congruent to itself, right? But these are just a different way of naming angle C. One's from the bigger triangle, one's from the smaller triangle. So then we get similarity through angle. Angle, similarity there. A lot of steps involved there, but a lot of this stuff you guys knew that. It's just, I think you want to skip things like you're solving an equation, because you guys are good enough at that stuff. You can solve all those things and you know these things are happening, but writing it out step by step is where I think you get hung up, because you're so used to moving faster than that, and you just can't do that. All right, let's try 6. Anybody get that one?
I got 2 parts of it.
2 parts. You got the given.
And I think I got something else, but I'm not sure.
All right, so let's get the given written in there. Hopefully everybody got that.
Okay, and then I did triangle LMN is similar to triangle PQR by side. To do that.
What do y'all say? Why can we say that those are similar by side? You got the ratios or the proportions set up where all 3 of them are equal to each other. Side similarity, that's what you got to have, and that's what was given to us. So we get similar triangles there. What do we know about similar triangles, Hayden? Go ahead. I'll hush. Those are ratios of the sides. Even though they don't give us any measurement, this is telling us, hey, the measurement of LM is the same as PQ, or the ratio of that is the same as this ratio, is the same as that ratio. So they're proportional, or the same ratio out of that. What's all congruent?
Both the triangles.
No. The angles are congruent. The sides are not. They're proportional. So that lets us take step 3 and get the angle that we want. Angle N congruent to angle R.
I got that, I didn't know what the reason was.
Well, what are these here? They're what corresponding parts, right? They're corresponding parts of similar triangles. Corresponding angles. I'm just writing it out long here. Of similar triangles are congruent. Corresponding angles of similar triangles are congruent. We know that's what's happening there. And if you don't know the name of the theorem, write out some sort of statement like that. So if we didn't know that was triangle sum in the last one, write out all angles in a triangle added to be 180. Tell me some sort of statement there. If you don't know the specific name of it, that's okay. Communicate to me that this is what's happening. I know this is what's happening out of that. So there's not a name for this. This is really what you have to write there. Okay. So nice and clean there.
Yeah, I did it there.
Good job. Good job. All right, let's try 7. They give us that RS is congruent to ST, and UW is congruent to VW, and angle R is congruent to angle U. All right, so let's get some stuff here. My first one, I'm just gonna do the segment parts. RS is congruent to ST, and UW is congruent to VW.
90 watt, 50 watt, Carrick Online, Katie Peters reports to office.
Okay, so this one's a little, you got to think a little bit here about what does that do. So It does. It makes both of those isosceles triangles. So I'm going to state that because what do we get with isosceles triangles? We get some two angles that are the same. The base angles are always the same on isosceles triangles. So we got to say that they're isosceles to get that to happen though. So we're going to say on step 2, triangle RST and triangle, let's do UWV are isosceles. And that's number 2. And that would be through the definition of isosceles triangles. What makes a triangle isosceles? What are the things? At least two congruent sides. That the statements that they gave us at the beginning, RS is this side here, and ST is this side over here. So that's two congruent sides. So that means that's an isosceles triangle. It may be equilateral, we don't know, but it doesn't matter. Isosceles gets us that. Same thing with the next statement there, UW and VW are these two sides. They're congruent to one another, so that makes that triangle also isosceles. Okay, and then because those are isosceles, we know that in step 3, we can say that angle R is congruent to angle T, and in the other triangle, what two angles are congruent to one another? U is congruent to angle V. And there's not really a name for this. We just know it, but that because they're isosceles, base angles are congruent in isosceles triangles. There's not really a name for it. It's just one of those properties of isosceles triangles. We know that that's what happens with the isosceles. There's not really a name for it. So it's just writing that statement out. This is what's happening. There's different ways to say that. The key that I'm going by here was written, I wrote it like this: base angles in isosceles triangles are congruent. Just wrote it the other way. It doesn't matter.
Next one means R and T are congruent and U and V, and then R and U are congruent. Does that mean T and V are congruent?
Okay, so R and U are congruent. That's our given. So I'm gonna bring that in because I hadn't put that down yet. All right, so angle T is congruent to angle U, and then we can get the T and the T is congruent to U through transitive. You guys have the punchline already, so. And then we know that angle U is congruent to V, so we gotta have, yeah, you could do transitive or substitution there. I would take either. So angle T is congruent to angle V now. Either transitive or substitution. I'm gonna use transitive. And then now we've got two pairs of congruent angles. So now we can get similar triangles. Triangle RST is similar to triangle UWV by angle, because we don't have anything about sides. We all got is angle stuff. And because that's happening, we want to prove our punchline there is that RS over UW is equal to RT over UV. Because if those triangles are similar, what do the sides do? They're proportional. So corresponding sides are proportional in similar triangles. There's not really a name for that. It's just a statement that you know to be a fact about similar triangles. Okay. All right. Short one here, and we'll get the last long one. FE over DE equals GE over CE. Everybody gets number one for free. You guys are pretty good at the bow tie looking ones anyway. Because what do you get for free in there? You get vertical angles. So we've got angle DEC, congruent angle FEG, vertical angles. Side angle side, because we've got FE over DE. That's this side and this side, and then the other pair of sides is there. It's the angle in between that we marked as vertical and congruent to one another. So yes, that's side angle side that we have similarity to. So 3 triangle DEC similar to triangle FEG, side angle side similarity. All right. So number 9, probably nobody did because it's super long. Or maybe you did. You looked at it. You did? All right. Got the first 3? Yeah, well, there's 3 things in the given. Good job. All right. So let's I'm not going to use all 3 of the givens at the beginning. I'm just going to use one at a time. Because I think it makes it a little easier to digest for this one since it's so long. Maybe it helps us focus on a few things. So angle MNR and angle PQN are right angles.
Mr. Isbell,
Yeah.
Caleb's all checking out.
All right.
Thank you.
Happy birthday. Congratulations. Okay. All right, and that was given. Do whatever you can with those. We're going to try to work on them. Yes. All right. All right. Now, so in my picture, I'm going to mark that. So MRN in there. So that kind of helps me sometimes when I get some information to put in my picture. All right. And then we want to use that to help us get somewhere to this. So how can I get these triangles similar, which is what I'm trying to do here?
Right angles are congruent.
Right angles are congruent. Okay, so we know that we could put angle MNR congruent to angle PQN. Because I'm dyslexic, I guess. Sorry. Thanks for being mean about it. All right, so thank you for correcting me. And then so we know that because right angles are always congruent, right? It's also legal to do like an extra step and say that the measure of angle MRN is 90 and the measure of angle PQN is 90, and that they're equal to each other, and then have like 2 extra steps in there. I'm okay with you doing this. Okay, we know that. That's just jumping straight to it. Okay. All right. So that gets us a couple of congruent angles. So that's good. That gives us the option of maybe going toward angle-angle similarity, but I don't have any other information about angles in my givens or in the picture, and I don't have anything about parallel lines either.
So did you do side and side?
Yeah, so that's what points me into trying to work toward getting side angle side. And that's half the battle with these proofs, is knowing what you're shooting for. What can you even try to do? Because if you don't have things about sides, then you can't do side, 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 or side angle side. If you don't have anything about angles, then you probably are stuck with side, side, side similarity. So with this one, we have an angle, and then the other given stuff is about lengths of sides. So I'm thinking side angle side is the best way to go here. So we're going to try to work toward that. So I'm going to take one of the givens and use it. So 3, I'm going to use that Q as the midpoint. Of NR. That was given. And then okay. All right, let's what Haley, what did you say? NR equals 2 NQ. Can't say that yet. Let's use this definition of midpoint to get that NQ is equal to QR. That's what the definition of that midpoint is going to give us. Then we can use the next thing to what you said there to help. You guys remember from all the stuff we did with midpoints, anytime they give you something about a midpoint, you know the next line should be something about equal pieces. Because that's what, or a bisector. You know, stuff's going to be about equal pieces. Now, the that gives us those things. And then Haley said 2 NQ, right? You said something about 2 NQ. Okay, so I can't just jump straight to that. I've got to build that up. So if I add NQ to both sides, is that legal to do? Yes. What am I doing there? Yeah, the addition property of equality. That builds us up to 2 NQ equals QR plus NQ. And that's just simplifying is all we're doing there. All right, now NQ plus QR is equal to what? Okay, so QR plus NQ equals NR. In our picture there, that's what's going on. That segment right there, that's what we're building. So if we built a segment addition. Been a while since we used that. The first proofs we did were segment addition proofs. Segment addition allows us to do that. But what do we know there? They're the same, right? So that allows us to then say that 2NQ is equal to NR, which is what Haley had said earlier, by either substitution or transitive, whichever way you wanted to do that, it's fine. Two NQ equals NR. Substitution. Okay. Again, it goes back to what are we headed toward? What are we trying to get to happen? Side, angle, side. And the sides don't have to be congruent, but they have to be proportional, right? So we're going to have to build a fraction at some point of the sides, okay? So when we look at that, NQ is the short side of this smaller triangle, right? What's NR? The short side of the big one, right? Those two should be in ratio, right? That's part of the proportion. Look at the last line we wrote. NR and NQ are in there. How could I get that fraction with those two sides? Divide by NQ. If I divide by NQ, 2 is equal to NR over NQ. Yeah, just division property. Okay. That gives us one ratio, that the ratio of those two sides is 2. All I have to show now is I have an angle that's congruent already, those right angles. Now I have one pair of sides that has a ratio of 2. If I can show the other pair of sides has a ratio of 2, then I've got everything proportional, side, angle, side, similarity. So the other given that we have not used yet, MR equals 2PQ. Let's look up here at our picture. Where's MR? The long side of that triangle, right? Where's QP or PQ? It's the long side of this one. Isn't that the right sides we need to get corresponding ratio on? So if I take this statement right here, can I do something similar to what we just did? If I divide by PQ, I get 2, right? So number 11, MR over PQ equals 2. And I didn't write given up there on number 10. And then the property there is division. All right, so then, well, we got to say those are equal to each other, right? Because here we have a ratio and another ratio. We got to say that those two ratios are equal. So I would say NR over NQ equals MR over PQ. Excuse me, by substitution would be fine. And now we have two pairs of sides and the angle between them, which gives us our bottom line triangle MRN is similar to triangle PQN by side angle side similarity. That one's a tough one, no doubt. It's long. Gotta, yeah, and it's a tough one. That's good. To start. Okay. So what are our takeaways from this? Our takeaways are you need to know what you're even trying to get done. What do you have to work with? If you've only got angle things to work with, you know you're shooting at angle. If you have sides only and no angle stuff, what are you shooting for? Side, side, side. If you have some angles and some sides, you're shooting for side, angle, side. Okay? So knowing what you have and what you're working toward are the keys to being able to do these